Chapter 5 is about Iceberg catalogs, and while it might sound like a dry topic, understanding catalogs is essential, because the catalog is the entry point for everything. Get it wrong, and you'll have consistency problems. Get it right, and everything just works. Remember from Chapter 2, a catalog has exactly two jobs. Store the current metadata pointer for each table, and support atomic updates to that pointer. That's it. This simplicity is why so many different systems can serve as catalogs. Let's walk through the options, and I'll tell you when to use each one. The Hadoop catalog is the simplest, using a version-hint.txt file for the current metadata version. On S3, non-atomic operations can cause inconsistencies, so it's mainly for local testing. The Hive catalog uses the Hive metastore with proper locking for atomic updates, ideal if you already run Hive. The AWS Glue catalog is fully managed and integrates with Athena, EMR, and Redshift Spectrum, making it the default for AWS stacks. The Nessie catalog adds Git-like branches, tags, and commits for multi-table transactions, and dev/staging/prod isolation. The REST catalog is a standard API for interoperability, decoupling engines from storage, and enabling flexible backends. The JDBC catalog uses Postgres or MySQL with ACID transactions for simple, self-hosted metadata management. I want to talk about Nessie a little more, since it's the most interesting and powerful one in my opinion. Nessie provides Git-like semantics for your data. Branches, tags, commits, merges. You can create a branch, make changes to multiple tables, validate everything, then merge atomically. This enables multi-table transactions, something no other catalog supports. You can have dev, staging, and production branches of your entire data catalog. If you need advanced versioning or multi-table consistency, Nessie is your answer. One more important topic: catalog migration. If you need to switch catalogs, you have two options. The Iceberg Catalog Migration CLI is a built-in tool that handles it automatically, or you can use Spark to programmatically register tables from the old catalog in the new one. Either way, only metadata pointers are migrated. Your actual data files stay exactly where they are. Let's review. The first question is, why is the Hadoop catalog unsafe for production on S3? Because it relies on atomic file rename to update the metadata pointer. On HDFS, rename is atomic. But on S3, rename is a copy plus delete, which is not atomic. There's a window where the pointer could be inconsistent, potentially causing data corruption or lost commits during concurrent writes. Review question 2. What makes Nessie unique among Iceberg catalogs? Nessie provides Git-like semantics, branches, tags, commits, and merges across the entire catalog. This enables multi-table transactions, where changes to multiple tables commit atomically, catalog-level branching for environment isolation, and a full audit trail of every change. No other catalog provides cross-table atomic operations. Review question 3. Why is the REST catalog becoming the recommended standard? Because it defines a standard protocol that decouples clients from catalog implementations. Any engine speaking REST works with any provider. Providers can implement custom logic behind the API. The implementation can change without affecting clients. And new features can be added without breaking compatibility. It maximizes interoperability across the ecosystem. That's Chapter 5. The key decision factors are: what infrastructure do you already have? Do you need multi-table transactions? And how important is cross-engine interoperability? For most new projects, REST or Nessie are the forward-looking choices.